So good afternoon, everybody. Thank you for allowing me to speak to you guys here in Wireless Field Day 6. My name is William Aguilar. I'm the Director of Product Line Management for the wireless portfolio. I'm responsible for the wireless portfolio at Extreme Networks Worldwide. I don't have slides as pretty as Mike did. I'm not in marketing, per se, but what we're going to try to do is really start peeling away the onion. I'm going to give you a little bit more details of what goes into our technologies, and then our senior architect in RF is going to take it even a step further, right? So thank you for this opportunity. As Mike indicated, IdentiFi is our portfolio name. A couple of things how we got to that name, right? So we were working with Gillette. We started working with them to try to identify, because we didn't really understand what the problem was per se. So we wanted to talk to the customer, understand what problem are you trying to solve, what type of devices are connecting to your network. Obviously, if your devices, 90%, 95% of the devices are one by one, then that's going to impact the design, right? You can't, take advantage of the extra spatial streams that are out there. So understanding what the requirements were, the applications that were running, which was video streaming at 300 kilobits per second, that played a role into our design. So after talking to them about those requirements, then we identified a solution. We identified the gaps in our own solutions, who Dionis is going to talk about, and try to address those problems from an RF perspective. And after the fact, after we did the actual installation, we had to continuously monitor to optimize the design, to optimize it based on the capacity in the stadium. So that verb identify kind of went throughout the whole cycle of that solution. So that's where the IdentiFi name comes from. And Mike mentioned the experience matters about. It's not only our experience in the industry, and not only on wireless, but also on the Ethernet side, right? So a lot of folks forget the Ethernet side, which I'm going to talk about in a few seconds, right? So if you look at our technology portfolio, I like to talk about a leg having a table having three legs, right? You can't have a table stand up if you don't have three strong legs on there. And in our case, the three legs are we call the access layer, which in the wireless world is the access points. In the wired world, you got your stackable switches, your modular switches, and so forth. We talk about our wireless core. Some people call it controller, some people call it manager. Depends what you call it, but at the end of the day, you need something in order to make that solution very, very scalable, right? And then we talk about our management. Now, when we talk about the access points, the access points are semi-autonomous in that when they wake up, they phone home, they get their configuration from the core appliance, and then they're running on their own for the most part. And I'm going to talk about how we do that by separating the control, the management, and the data plane in our infrastructure. So a lot of the stuff happens at the access layer. Obviously, the quicker that you are to react to the data in your network, then the more efficient that your solution is. So you want to take it in the ingress port as much as possible and provide a lot of that intelligence out at the edge, right? When we start talking about now, another thing about access points that's kind of interesting is that everybody talks about access points being a commodity. And when you start looking at it, it's not really, because I used to be a switching guide. And if you took a reference board for a stackable switch from one of the switching vendors, you just could put it on your own box, and off it went, and it ran fine. You can't do that with wireless access points, right? Because the footprint matters, the way that you put the radio, the filters, and so forth. It all has an effect on what the AP is coming out. And we're talking about, for example, spectral mask issues that you have to address. Now, there's a couple of things that you can do. You could lower power, that reduces your cell size, or you could fix it adding additional design elements into it. Another example is heat. The hotter it gets, the worse those radios perform. So you need to ensure that you dissipate that energy, because you don't get a consistent throughput. So there's a lot of intelligence that still goes into what most folks consider just a commodity piece of network equipment, right? On the wireless core side, because of our flexibility, we've been able to virtualize it. So we can run it on a dedicated appliance, and we'll talk about why, in a centralized mode if you wanted to send the data path through a centralized design, or we can also run it in a virtual world, right? We virtualized it over 2 years ago, and the reason for that is because it's only software. So because it's only software, we could put it anywhere in the cloud. We could put it, in your internal cloud, your external cloud, private, whatever it is that you want. It's really a piece of software if the access layer is intelligent enough to address the data path. Right, so we'll talk about that. And then wrapping it all up, and our third leg is the management piece. And the management piece is multi-tier. So in one sense, the management piece, we were first in the industry to provide the ability to manage both your wireless and wired network from a single application, so a single database. And it's not just configuration and monitoring of that, but it's actually enforcement of policy that we're going to talk about in a few slides. So a very adaptable infrastructure, right? So how are we unique? Everybody in the world, there's a lot of vendors out there that can provide Wi-Fi connectivity, right? But what makes us different, right? And what we believe makes us different is our focus on ensuring that there is no bottlenecks in the network, right? So density, high availability is critical to our infrastructure. We don't charge anything extra for high availability. It's built in to the base of our solution from day one, right? We've always considered Wi-Fi to be a must-have, not a nice-to-have, right? So because of that, from day one, the design of the solution was designed for that. The density we're going to talk about, right? It's not just about RF, but we're going to talk about different issues that give us the ability to support a lot more clients than somebody else, even though they may have additional radio capacity than our solution. Right. Flexibility. We can't tell customers how to run their business. Customers know better than we do. Right. So we need to ensure that we have the ability to adapt to whatever the customer's needs are. So that means we can't dictate to the customer, no, centralized is the best way to do it, so you got to do it that way. Or distributed is the best way to do it because you got to do it that way. The customers know their networks, their needs better than we do. We need to be able to provide them the bells and whistles and all the buttons and turns to make sure that we adapt to whatever their needs are. Right? Visibility and control is critical. Right? I was in Madrid, I think 2 or 3 years ago, and kids went to in college, kids went on vacation, came back, 2 weeks later, 3 weeks later, 60% more authentications in that Wi-Fi network in 3 weeks, right? So if you design your network at 50% capacity, you just lost that, 50% in 3 weeks. So the ability to know what's going on in your network, who your users are, what applications they're using, that's critical to figure out how am I going to optimize my design to address that. I don't know how many customers I've gone to that say, I don't know, I think I have 5,000 users on my network, but I have no idea what they're doing. I don't know what they're using, 2, 4, 5. I don't know what operating systems they're doing. So if they don't know that, then how do you fix the problem? So the first thing is trying to understand what the problem is so that you can address it correctly. And we talked about the unified management piece, right? So that's what we make different. Now, one of the components that we focus a lot on is it's a separation of the management, the control, and the data plane, right? This is critical to the success of your deployment, and it makes makes things like density, more addressable when you have that flexibility. So on the management side, as I mentioned, we have a management application scalable, but you can also manage from the core directly, right? So you can we have different tiers of management to address that. Our management solution, this is where you get your configuration, your statistics, your reporting. You could do it on the wireless only. You could do it on the wired and wireless side, right? And by the way, it doesn't all have to be purple extreme switches across the board, right? We could support a heterogeneous environment. For example, at Gillette, it's an end-to-end extreme network. At Lincoln Field, it's not. The wired solution is provided by another vendor. We provide the Wi-Fi coverage. So we're able to work in a heterogeneous environment. From the control perspective, we're talking about a distributed or a centralized approach. We could do either, and in order to do either, you can't take any shortcuts things that you do in a centralized approach you can't do in the access layer. So you need to be able to do both things consistently in both places in order to be able to support both solutions. RF management, for example, on the AP side, there is no dependency back to the wireless core in order to, for example, load balancing users, band steering. All that things are done at the AP itself. So that makes it, a lot more efficient, a lot less dependency on that centralized approach. And then the data piece is critical, right? Because in the early days of Wi-Fi, obviously we had standalone APs. When Wi-Fi started growing on the enterprise, we had the centralized controller-based solutions, and that was great for ABG. But then when 11n came around, now the controllers or that centralized became a choke point into your network. So now you had to replace your APs, so you spend money there. Some cases you had to replace your switches because they didn't provide enough PoE power, right? And then you had to replace also the core, very expensive core appliances. So that was really was a killer for that type of centralized approach. So the ability to distribute that traffic is critical in eliminating that in your network. So let's take it a little bit more. As Mike mentioned, we've had the ability to do both wireless and wired and wireless managed since actually it was early 2008. He said late 2007, but close enough, right? And this gives us the ability to have visibility and control all the way from the wired and wireless access all the way to the data center, right? So that's critical because I know we're wireless guys and we don't think about the wire side, but the data center, the things that the dynamics of a data center are very similar to the mobility dynamics of a user, right? When you have a server moving around all over your network, it's very similar that when a user is moving around the network, right? So you could use the same type of solution and infrastructure to address both problems. So it's a good solution from that perspective. We also have an extensible northbound API. So if you wanted to, and I'll show you a use case of where this may be useful. But if you have another device like an MDM device, for example, that you want to know the status of that device in order to allow or change the profile and access into your network, you're able to do that by extending our management layer from that perspective, right? On the wireless side, so if you switch over down to the wireless side, you don't need our scalable management solution to manage the wireless network. That's available through the wireless core, right, or the wireless appliance. And as I mentioned before, you can manage these devices securely. Out of the box, we could support a sub-second failover in thousands of APs. So our biggest box supports 2,000 APs. We only sell half the capacity of the APs. Why? Because we give you the other half for free for high availability. Right, so if you have a 2,000 appliance solution, we only sell 1,000 AP licenses. You get the other 1,000 for free, so that when you have a bad day, I like to say, we only have one bad day with us, which is when you lose your core, your WAN link, or whatever your outage is. With the other guys, you have 2 bad days. First, when you have to pay twice for all the licenses, and then when their actual solution, the core goes down.
Can you explain that again? Sorry. So a 2,000 AP controller can handle 1,000 APs in HA. Is that what you're saying?
No. So for example, let's say you had a 2,000 AP deployment, right? So you'd have two core appliances, one for 1,000 licenses, the other one for 1,000 licenses. One of the core appliances will support another 1,000 on top of that. So in a 2,000 AP deployment, you only buy 2,000 licenses.
2,000s are adding up and giving you
exactly. So we'll give you the other 1,000 capacity on the other appliance, right? So it's half the cost that would be otherwise, for another solution.
And if for some reason it wouldn't be common, but if you didn't want HA at that scale, then you could have one with 2,000, obviously.
No, so it's included. So today our design is included by it. So we'll say you're up to 1,000 capacity and you get the other 1,000. But if you decide you can't put the device in active passive mode, right? It's always active.
If you just bought one controller though that supported 2,000 APs.
No, you'll get 1,000 maximum.
Right. So it's really 1,000.
No, because 95% of our deployments are high availability pairs.
Sure. Yeah, I'm not saying it would be common that you would want a single controller, obviously. But
no, yeah. So we designed, as a product manager, I designed to the 80-20 rule, right? So I'm going to try to cover as much of my customer deployments as possible. So this gives us the best advantage. But it's a good point. It's something we looked at, especially on the virtual side, with the ability of the virtual environment to move applications. That's something that we definitely looked at to give you the ability to add those into our Sparta, and you choose what you want to do with it.
And how is guest traffic handled then? Is it more of a traditional deployment where there'd be a guest controller in a DMZ, or?
So we're going to talk about that, but that's a perfect example of a centralized approach, right? Where you tunnel the guest traffic and you egress out of the centralized location out to your DMZ, right? But we also have another mode where you authenticate the guest user, right? And after that gets user authenticates, you drop them directly in the distributed mode. So the first authentication attempt or the first redirection goes to a central point, right? But after that, the data traffic gets dropped directly at the...
So it's still being trunked out into your internal network, and then you've got to have ACL, not that that's necessarily an issue, but you've got to have ACLs or whatever pushing it into your DMZ. Or
it comes directly from you could come directly from the controller, from the core, directly to your DMZ if you wanted to. You can egress out from there. If you don't want that...
tunnel or just
through a tunnel, you can encrypt it, or you can leave it open if you want.
Yeah. So in other words, you don't have a controller sitting in the DMZ as a tunnel endpoint.
So,
but what is what would the traditional architecture be that you'd recommend?
That's typically what we've done, right? So you have a controller in a central location, and you have a dedicated interface on that controller that you're plugging into a DMZ or DMZ-like segment.
Okay, like a separate physical interface.
yeah, exactly. If you wanted that separation, you could.
Right. Okay.
And the high-end support 1 gig and 10 gig SFP pluses, so you could go different ways from that perspective. All right. So on a high availability deployment, which I mentioned is more than 85% of our deployments, right? The configurations and all the policies and everything on the user sessions are synchronized automatically between the high availability pair. So it's a sub-second. What happens is the APs create two sessions down out to the core, so that if for some reason you lose WAN connectivity or the device goes down, the AP already automatically has another connection out to the session. No reboots of the AP. Everything continues to operate, right? One thing I didn't mention is our heritage, before we became more of a data-focused company that we are today, right, was voice over IP in hospitals. So our solution has to be, was designed for those, low latency, high mission critical deployments all the time. In the last, since 2007, we've added the data convergence on top of that, right? So the bandwidth, the additional bandwidth that you need for video on demand, and the different components of that. But from a low latency, quick roaming, all that's built in to the solution, or was built into the solution from day one. All right. So we talked about distributed management. So now we talk about the control plane. And as I mentioned before, the access points are they're not dumb, right? So all the functionality, or a lot of the functionality from a control perspective that you would apply on a central configuration or a centralized deployment, you can apply on the distributed platform, right, or in the distributed mode.
Are there limitations on the number of APs that can be supported not on the controller as a whole, but if you've got a large branch office, are there limitations there that mean?
No. So we have something called sites mode, where you can have up to 32 APs authenticating directly from the 32 APs out to your radio server, for example. So you don't need to go back to the centralized point to authenticate. But those 32 APs, you can make multiple of those sites mode, right? So the reason we keep it low is because your session data, if you think about an AP, there's limited amount of resources in that device. So there's a maximum of about 1,000 users that you need to be able to keep as you roam around in those 32 APs. We need to be able to keep that session data dynamically across those devices.
If you had a site, if you had 300 large sites, I'm just giving you a more extreme example.
Sure.
You don't want to put a controller in each of those sites.
Sure.
And each of those sites have 200 APs each. So
Yep.
could you use the distributed mode?
You could use the distributed mode, right? There's two things or there's actually only one thing today that you need to go back to the centralized point, right? And it's your guest portal redirection. Right. So everything else you could do directly on that site, right? And the information that goes from that site to the centralized management platform is really statistics, user sessions, report, that kind of stuff that you need for that information.
So are there any limitations sharing cached keys if you're doing OKC or?
Yeah, so for rapid roaming, we support OKC. Dionis, I don't know if you want to talk.
The site will exchange information with each AP to each other AP. There is a
not a tunnel. But
and there's not a limitation on AP quantity there.
No, well, the AP is, like I said, it's 32. You could do 32 of them in one group.
So that would mean if you had two lots of, let's say you had an area that needed 64, then you would have
two sites.
You wouldn't have fast roaming basically between.
Yes, it will not have fast roaming, and at this moment the design of 32 is designed basically replacing our previous controllers, which were going in the site, but we can grow that limit. This is almost an artificial limit that we can grow.
I mean, in those cases, sometimes you can design around it. You know, if you're able to put 32 per floor or on a transition point.
Yep.
You know, to try and minimize.
Yeah. Yep. Basically, the site works as one common distributed system. They exchange information between them, and including keys and session information, policies, everything which otherwise would have come from a centralized place.
Right. Okay.
So we talked about client load balancing. So this is critical when you start talking about high density, for example, right? The ability to balance clients across radios or even across APs in the same line of sight. So this is critical to be able to do that. And today our solution doesn't have any dependency on the client side. So we're able to leverage that technology to be able to move connections across radios on the fly and across APs as long as they have line of sight. And you as an administrator define how pervasive that's going to be. We talked about spectrum analysis, wireless IDS, wireless IPS. That's part of that. I'm not going to drill too much on it, but because maybe it doesn't have we have other things that we want to talk about from a stadium or from a high density perspective, but certainly the spectrum analysis is critical for for places to understand if I'm having a lot of interference or my my signal to noise ratio is high. There's different. This is really critical in order to be able to see that and trying to start understanding what the problem is. So if there was any secret sauce to it, when every time we have a marketing or somebody come in, it's like, hey, what's your secret sauce? Is there a silver bullet? And there isn't, right? It's a combination of many things, right? One of the things that we do differently is the idea of policy. And policies has been watered down over the years, but what policy means to us is the ability to create rules based on business services and those a role-based access control for that user, right? And based on that user provide different levels of access, right? And it's VLAN and SSID independent. This is critical because if you talk to Ethernet vendors or switching vendors, right, a lot of their policy-based or their role-based solutions are based on VLANs, right? So every time you have a different role, you have to put that user into a different VLAN. So that requires a lot of management because now you got a lot of VLANs running all over your network. And makes it very difficult to manage. You take it down to the wireless side, and a lot of wireless vendors use multiple SSIDs to provide that role-based access control, right? The more SSIDs you have over the air, then the less efficient that your network is going to be because of all the beaconing that goes down. So it's critical that you provide not only the access control piece of it, but also the traffic engineering piece of it, right? All together within the same SSID. Okay, and I think, now we did this, so we talked about future-proof early on. This technology was designed over 15 years ago. Before Wi-Fi was the density of Wi-Fi, bring your own device, data center virtualization was even available. And that same technology has been expanded to address these situations. So I don't know what's going to happen 5 years ago, right? But we have a strong infrastructure, a strong foundation that we feel can adapt to the industry and to the industry's news as it moves around. So an example of this, let's say you had a doctor and she has two different devices, right? She has her own personal iPhone or Android device, and then she has an IT managed asset, right? So she may be using PEEP. So she may be using the same user credentials that she uses to log into her system, right? But we're able to identify where she's connecting or what she's using to connect from. And based on that information, we could say on the fly, oh, by the way, okay, you're connecting from your personal device, so your access is going to be directly to the internet, right? You're not going to be able to have access to the data, to the patient records. Now, when she connects, same user ID, same password, right? If you want to, right? We have the ability to identify that user now is coming from a different device, and that's an IT asset. And because of that, we're going to treat her differently, and now we're going to centralize that traffic and run it for her to allow to get patient data.
Can I just ask, in this scenario, what is the differentiation? or an example of the differentiation between?
So the differentiation for us is that on a single SSID, we could treat her traffic differently. So when she comes in on the same SSID, right, she comes in from that device, we could tunnel that traffic, or if she comes through another device, we could bridge that traffic down at the access layer.
I'm more asking
determining the difference between the two devices.
Yeah.
Well, fingerprinting that device, right? DHCP fingerprinting, you know, different things, right? You know, the easiest one is user ID and password, right? But if she's not, if she's using PEEP and she's using the same credentials to everything, then there are other ways that we identify that device.
So if I've got a corporate issued iPad and a personal owned iPad, and I log into my corporate issued iPad and my personal owned iPad with the same credentials and the same SSID with the same authentication mechanism.
Yep.
What happens? What happens if I'm
So
using
then that's where you get MDM in this stuff, right? So if you have an IT managed asset, right, that means that you most likely have some other application installed on that device, right? And now we can depend, oh, sorry, that didn't work. Let's see. So she connects with that asset, and for some reason that device is out of policy. She forgot viruses, she forgot whatever the case may be. So we're able to leverage, right, an MDN application to tell us, hey, you know, she can't fit in that profile. So that device is out of policy, even though it's an IT asset.
And so I identify as a solution contains an MDM?
No. So that's the other part. We talked about third-party XML API, right? So this would be a use case for it. Right, so somebody like...
That's a little bit misleading, right? Because you just got done saying, hey, IdentiFi supports this granular slice and dice of, hey, you've got a corporate issue blah and you've got a personal issue blah. And then, you know, you get down into the weeds and it's, oh, well, the solution really requires this other widget over here in order to do that sort of go, no-go control. So it's not a part of the IdentiFi solution. It's a separate piece that you've got to go buy.
So right? It depends on the granularity that you want, right? So can we
differentiate? I mean, the ones on the screen, right? Personal asset and IT asset.
Yep, and that's what it shows the third-party consulted, right? In that case, so if you want that level of granularity, that you expect that device to change. So the status of that device changes on the fly. She forgot to, whatever the case may be, she's out of policy. She forgot to load her antivirus and she hasn't loaded in a while. I mean, one thing that the industry doesn't know, right? BYOD, it's NAC, right? NAC had a bad connotation over the years, but it came back because of the needs of BYOD, right? So the ability to fingerprint that device and then go into it, and not just the pre-assessment, but the post-assessment part of it, right? That's where you get that level of granularity that it's not built into the wireless solution, it's built into other components, and we adapt and are able to respond to that. Okay? So what does everybody overlook on the wireless side? So everybody on the wireless side overlooks the Ethernet side. So, you know, we've been in many, POCs, proof of concepts, where customers want to see how our technology behaves with other solutions, right? So in that case, what we've seen is that we've actually outperformed devices that were 2 generations newer than we were. So our 3x3x2 solution from 2007 could outperform a device that was 3x3x3 from a couple of years ago. And when the owners did the calculation, we couldn't understand why. It came down to our ability to handle packets per second at a higher rate on the Ethernet port than anybody else, right? So we spent a lot of resources. So some of you are shaking your head, and what does that mean? So you can have the biggest radio in the world, right? But if you don't have the ability to process that in softpath, you got to take that data from the radio. It's got to go through the CPU, through software, to get it back into the Ethernet port. And if that's your bottleneck and you drop traffic, what happens? You have to resend it. So I don't care how good your radio is and how good your antennas are, but if you don't process that data fast enough, you drop it and you have to resend it, right? And this is a critical aspect of the high density solution, right? Because at Gillette, for example, you know, the smart guys, I'm not smart, but the smart folks did a lot of testing in the lab. On a one-by-one device with 20 megahertz channel, the maximum you're going to get over the air is 30 megs of traffic, right? So in that case, in many cases, the RF medium is the limitation, right? We could process, as long as the CPU can process that data, right, you're okay. But now, if you get to a 2x2 devices and your data rates go up, and you have a lot more data because, or you go to 40 megahertz channels, now your bottleneck becomes the CPU unless you can handle that data traffic very, very, very quickly, right?
Well, I think in a high density, I think your bottleneck is the contention in the air, and it is the Ethernet capacity or even switching on that.
Yeah. So
when I start to look at my radios, I mean, I have 22,000 clients, and even consulting with Lee, who's at the university level. We don't see that capacity. Now, maybe in a stadium you do, but in testing that we've done at the hospital, the limitations in the air, not necessarily the. I don't know.
Yeah, I agree. Completely agree. Depends on the problematic. So in the stadium or high density areas, contention can be bigger problem, especially with devices 1x1 or 2x2. However, in some other areas, like schools, we have seen the requirement is 30 iPads streaming 720p continuously. Then it's not so much the air becomes the CPU because packet per second goes up. Especially when you go with 3x3 devices, there are not too many of them, but they are out, and you measure against them, then air is not any longer the problem. Especially devices do well aggregation, cell is well designed with high fire rate, you end up that CPU starts to become your problem. And historically it was like that. We started ABG, 20 megabit per second, maximum we can achieve, CPU was never a problem. As we're going up, the CPUs are more and more bottleneck. In the cases where it's exposed, when air can handle that. When air cannot handle it, of course, CPU is not the bottleneck. It's not the slowest link.
How often is that? Would you think that would be the case?
So, I mean, the use case that we saw was they had 40 devices in a classroom, and they were running video streaming, right? So in that case, that was the proof of concept that the customer wanted to check. And what we found out was a lot of the other devices could only handle 12, 16 connections because of that, because the bottleneck looked to be the CPU, right? So, as you mentioned on the stadium deployment, when Dionis talks about, we addressed a lot of the RF bleeding issues because there is a directional signal, right? So now the RF doesn't become necessarily the bottleneck. It's other places in the network that you need to address.
Can you touch on hardware-based IPsec tunnel acceleration in your virtual controller platform?
So yeah, so we have calls on the virtual platform to make down to the physical hardware. So if the physical hardware has a crypto accelerator on it, then we communicate through the VMware layer to access that.
And is that done through hardware pass-through, or is it just automatic through the hypervisor?
I think it's done through the hypervisor.
I can maybe explain. Our solution is based on Intel platform and use AES-NI support from and built in the CPU, highly parallel. We have 24-core parallel systems, the higher variant. The smaller variant, the virtual, is we are 4-core parallelized. So if the underlying platform supports AES-NI, we automatically enable it and use it. If it doesn't, then we do in software.
You do in software, okay.
Yeah.
So there's other things that we do. So for example, we don't take the off-the-shelf drivers from Linux. There's a lot of other work that we do to make sure that we can process packets, faster. So instead of swapping back between memory, we take it in the ingress port. We carry that memory unit across the board to make sure that there's not a lot of thrashing, right? Because from a network perspective, there's a lot of specific things that you need to do to ensure an off-the-shelf platform like this will operate, doesn't become a bottleneck, when you start processing network traffic, right? There's a similar thing, on the Athero side. We do our own scheduling. We do a bunch of work to make sure that we optimize those packets when they come out of the air. All right. So if you switch over, you have the centralized data plane story, right? So why would you need a central data plane? Well, the customers tells us when they need it. But a couple of examples are, if you wanted L3 roaming through your whole campus, right? And this is building to a problem when you start getting into the centralized environment, right? So for example, you have 12,000 APs all over your campus, but you want your users to keep that same IP subnet and they roam across the whole network, right? In that case, the centralized design is beneficial. And in that case, you're not limited by the access layer. So if you distributed that traffic, there's a lot of tunneling that you need to do between APs and other APs as that user moves around. And the hardware of APs is not necessarily designed to address that, right? So that's where the centralized design really shines. Another example is a large venue stadium. Why? Because the way depending on how you design the network, you may be sitting here with your iPhone, but as soon as you go here, you may connect to another AP. So if you have to switch that subnet, if that user needs to re-authenticate, or if that's the case, then it becomes a problem. So in our specific stadium designs that we use, we segment those users when they come in randomly through the gates, right? And we segment those users to make sure that they always have the same IP address no matter where they are in that stadium. And that ensures continuity, so that if you're looking at your video stream, it doesn't matter what AP or where you are, you're going to have the continuous, or you're going to have that user experience that you would expect, right? And then, as we mentioned before, guest services, right? So if you don't centralize guest services, which you don't have to, but if you do, then it makes it a lot easier to be able to provide, as an old security guy, certainly VLANs don't give you any protection from a security perspective, but if you wanted to segment that traffic, tunnel it back to your centralized core, and then egress out into the DMZ, you could do that in a centralized approach. If you did it separately, if you did it differently, and you moved all those connections down to the access layer, that's a lot of VLANs that you have to define in your switches, right? So you got wireless vendors that say, hey, I make everything very easy on the wireless side, but they forget about the wire side, you know? And you can't look at it as just one approach. You got to look at it holistically, okay? So an interesting use case that really brings to light some of the issues with a centralized approach is Bonjour. And is everybody familiar with Bonjour, not the French version of it for the Quebec guys, right? So Bonjour, obviously, you guys have experience with it, that it's really difficult to manage on an enterprise, on a large-scale network, right? Bonjour works great for what it was designed to be, right? Plug and play for a consumer network, right? But it's a link local protocol. It won't go across subnets, theoretically, right? So you need to be able to, so how do you scale it, right? Other issues with multicast over the air is that, you know, traditionally you send it at the minimum, you have to send it at the minimum basic rate, because, you know, you need to reach everybody on that AP or in that wireless network. So you got to send it at the lowest rate, which means you take more transmit time, which is going to affect the overall performance of your network. You know, battery life is another aspect of it, because if you're using UAPSD, that device is asleep. You can't wake up that device on a whim just because you have multicast traffic. So the buffers on the APs have to, you know, preserve that data until the DTIM time comes up and those devices wake up. Well, guess what? You're contending with other multicast traffic that's important, like ARP, potentially, right, on those queues, right? So you really need to find a way to address that and become more resilient to that environment. So let's take the multicast piece of it, right? So we do a lot of we've added a lot of functionality on the multicast side. So we filter multicast both at the AP and in both a distributed and a centralized approach. We do proxy ARP in both places. So by proxy ARPing, you reduce the amount of broadcasting or multicast that goes over the air. So it's all about improving the resiliency of it and reducing that, right? We do additional stuff, so when we drop, so if our buffers get over full or filled up on the multicast side, we don't drop, you know, we don't drop critical traffic, right? So we rather drop a multicast traffic not related to the network being up than something else. So there's algorithms in that perspective. The other thing we do is that we intelligently convert multicast to unicast up to a point, right? So depending on how many users or devices are connected to that AP, in some cases, if they're at a high rate, right, you can become more effective by sending multiple unicast streams at the rates that those clients are connected. But at some point, you know, we have the algorithms that say, you know what, it's still going to be more efficient to send a single multicast packet at a lower speeds than to send multiple unicast packets at higher rates, right? So we do that all intelligent. And then finally is another thing that we do is, instead of sending at the minimum basic rate, we look at who's connected on that AP. And based on the lowest common denominator, we send at that rate. So maybe your minimum basic rate is set to 6, right? But the slowest connected client is connected at 24. In that case, instead of sending multicast at 6, we send it at 24, right? And what does that mean? We get the radio back quicker. You can transmit more. So it reduces the impact of multicast on your network, right? But there's another piece of it, right? So back to the traffic engineering piece, right? So we talked about how to control multicast. So multicast now is all over your network. So what some competitors are doing is they're taking the multicast traffic, they're proxying it across multiple subnets and amplifying the problem across the way, right? So instead of trying to control the problem, they're amplifying the problem over making it worse in your network, right? So what do we do with our policy approach? We could do a couple things that are not very interesting, right? So if you have a centralized data plane, we could send your unicast traffic to your wireless core, and we could send your multicast traffic to the wireless core, but put it in a different VLAN, right? Okay, that's one way of doing it. Not very exciting. We could also do it on the distributed side. So you take your unicast traffic, your multicast traffic, and one of the actions is you identify that, UPnP or LMNR or Bonjour, right, and put it on a separate VLAN, right? Still not, it's cool, but not as interesting. But what if you could do both on the same user session, right? So for example, we have higher education customers that use a centralized design, right? But now that multicast traffic has to go all the way across their network to the core to come back. Where, what if you could like I said, I need a beer. Oh, your wine. I need Kim, I think. But what if you can contain that traffic and contain the problem, and you decide where that containment is? And this is what we're able to do differently. So we talked about what makes us unique before. From a traffic engineering within a single SSID, we can have different roles, but we can treat that traffic differently on those roles. Now we're taking it a step even further, that within a user session, we could treat traffic differently, depending on what that traffic is, right? So what does that mean? So if you take, for example, a small classroom, right, and you have an Apple TV in that classroom, right, if you had a centralized design, you're going to run multicast all over your network. Right? So what if you just constrain that, right, to that AP, right? So you could do that with the multicast rules. You don't need to do any VLAN containment in that case, right? But what now if you had a lecture hall that had multiple APs, right? So now you can say, you know what? I want to be able to have that lecture hall, and I want to constrain my multicast traffic to that lecture hall, to those APs in the lecture hall, but I'm still allowing my unicast traffic to flow to the core. So I still have the mobility of centralized, right? But now I'm leveraging the flexibility to get the benefits of a distributive approach. Okay, so you decide how big that needs to be. How big does my VLAN needs to be? Maybe you have Apple printers on a whole floor with 32 APs. So you decide, you know what? My whole floor, I'm going to run Bonjour there because I need those devices to print, right? Or you can, constrain it to a classroom, or you can constrain it to a lecture hall. So you decide how big or how small you wanna make that problem.
So, question, is that, so having the local Apple TV on a VLAN, is that on the same VLAN as the AP?
No.
Separate VLANs?
It could be in a separate VLAN. And you decide from the wire side how far or how small you want to propagate that VLAN. Right? So for example, if you had these 3 devices connected to a single switch, you just don't egress that VLAN out of that switch. Right? So that gives you that constraint. So you could use the same VLAN on all your switches. As long as you don't egress that VLAN at the uplink port, you got the isolation that you need. Right? If it's across switches or across sites, then at that point, then the VLAN management becomes, you decide how big or small that VLAN has to be. But it's not, it will be a different VLAN than the unicast traffic if you want.
So you're breaking up the link local multicast domain across.
We're not. We're keeping it on the same we're keeping it in the same VLAN. So we're not going across subnet boundaries, right? So what others are doing is they're taking a protocol that's getting broadcasted on that subnet, taking it and putting it in another broadcast domain.
Yeah, what I'm saying is you're breaking up that. Yeah, I could have the same wireless network everywhere, but only clients connected to that AP. You're going to see multicast from local Bonjour devices plugged into that switch. So if I go to the next building, I'm not going to see that traffic.
You decide. If you wanted to, you could, right? Because you control it based on the VLAN, which is not your unicast VLAN, right? It's a separate multicast VLAN. And this is a problem that was solved 10 years ago on the wire side, right? By the similar situation. So that's where our experience makes sense, right? Because we're using ideas and rationale and things that worked in a grand scale in a wired environment, and making them work or using those ideas, that information that we learned in the last 30 years and applying that to the mobility side of wireless.